So now as I look at part C, I once again notice that I have two logs on the left-hand side and a constant on the right-hand side. So one more time, I cannot use that trick from part A because I don't have a log on the left and a log on the right. So I can't just drop these logs. So what I'm going to have to do then is use something similar to what we did in part B. I have two separate log pieces on the left-hand side, and I want to rewrite them so that we have just one log. So, okay, thinking about the ideas from the previous section, we have this idea that we're going to use the exponent idea first, so I'm going to bring that power of 2 up. So we're going to have log base 3 of the quantity x plus 4 squared minus log base 3 of 9 is equal to 2. Now I have a log minus a log. I remember that there's a connection between subtraction and division. So I can bring this together as one log, log base 3, of quantity x plus 4 squared divided by 9. And that's equal to 2. Now, one more time, as you look at this problem, notice we don't have an LOG on the right-hand side. So that means that I can't simply drop the logs. So I have a logarithmic equation. I'm going to have to rewrite this logarithmic equation as the equivalent exponential statement, and then I can move forward with this problem. So base of the exponent is going to be 3, just like the base of the log. Logs are exponents, so I'm going to have a power of 2, and that equals our result of x plus 4 quantity squared, all divided by 9. Well, 3 squared is 9, so we're going to have 9 is equal to x plus 4 quantity squared, all divided by 9. Now, as you look at this, notice that we have a fraction on the right-hand side. I want to get rid of that fraction. And if I multiply both sides by 9, that will do that. So multiply by 9, multiply by 9. We're going to have then that 81 is equal to x plus 4 quantity squared. Now once again, lots of quadratic ideas will allow me to finish this problem. I'm going to go ahead and choose to use the square root property because of the way that this particular problem is set up. So square root property, remember you have that plus or minus symbol that always pops up, and then you have the square root of 81, and that's going to equal the x plus 4. Well, square root of 81, that's 9. So we have plus or minus 9 is equal to x plus 4. Subtract 4 from both sides, and I get that x is equal to negative 4 plus or minus 9. Now that I have this, remember that if you have something where the items before and after the plus minus symbol are both the same kind of number, that means that you should actually bring them together because you have like terms. So let's go ahead and bring these together, and I have negative 4 plus 9, and then I also have negative 4 minus 9. So if I have negative 4 plus 9, that's going to be a positive 5. And if I have negative 4 minus 9, I'm going to get x is equal to negative 13. So once again, it's tempting at this point to say both of those are answers. They must definitely be solutions. However, one of them, or maybe both of them, might be extraneous. So you always need to double check your answers. So let's start with this x value of 5. Is it possible to have a positive x value and then end up being that one of the arguments is negative? Yes. So you need to double check even these positive x values and see what happens. So let's double check. So if I plug in this x value of 5, right here I have 5 plus 4 in my first argument. 5 plus 4 is 9. That's a positive number. I can take the log of a positive number. There's nothing wrong with that. And then over here the argument is positive, so we're good there as well. So 5, absolutely no problem with that. Well, what about the other one? Negative 13. So plug in a negative 13 for x and see what we see there. So let's plug negative 13 in here. Negative 13 plus 4, that's going to be a negative number. So because the argument is negative, I need to exclude that negative 13. So at a minimum, you want to come in and cross off that negative 13. But again, your author likes to go ahead and just use the solution set to demonstrate the fact that he's checked. So let's do that. I'm going to say that I have a solution set that contains then the only number that is a true solution, 5. And we're done with the problem.